Let us start today's class. Today's class is all about problem solving from chapters 11 and 12 together. So I will solve like 5 or 6 questions from chapter 11 and then 4 or 5 questions from chapter 12, covering the whole regression, the simple linear regression and the multiple linear regression. Before I jump into the problem solving related to chapter 11, here is the summary of chapter 11, where we said we have a simple linear regression model denoted by this equation. In this equation, we have two unknowns, beta naught and beta 1. We estimate them using these formulas, which are given to us in the formula sheet. These formulas are obtained by using a method called minimizing the sum of squares of errors. After estimating these coefficients, the next step is to do the hypothesis testing. We, in chapter 11, used only t-test and we used f-test for testing hypothesis. T was for testing the significance of a single predictor. F was for testing the significance of the whole model, but they both became same. Why? Because only one predictor. So T and F, they gave us the same decision, same conclusion. Then we also defined a measure to check how good is your model. This measure was called R square. This R square measures the amount of variation in Y, which is explained by your regression. And luckily, it came out to be equal to the sample correlation, but this is not always true because in multiple regression, R square will have a different meaning. So don't keep this rule. Don't generalize this rule to every situation. And then we use the fitted model for what? For two purposes. What was the first purpose and second purpose? The first purpose was to estimate the mean of Y when X is X naught. And the second purpose was to predict the value of Y when X is X naught. The point estimate for both of these purposes was the same, but the interval estimate was different. Now let us move towards the problem solving. For the first question, it says that an engineer at a semiconductor assembly plant is investigating the relationship between the pull strength and the length of the wire. Pull strength of the wire bond and the wire length. He takes a sample of 25 units and observes the pull strength and the wire length. We assume that the pull strength and the wire length are jointly normally distributed. We fit a simple linear regression. Pull strength is Y, wire length is X. It is very important to identify the direction of relationship at this point because there are many questions where you mix up what is X and what is Y and the whole thing becomes wrong. So identifying correctly from the question that what is X, what is Y is very important. Sometimes it is clearly mentioned, sometimes it is not clearly mentioned, but it is very important to identify which variable is X and which variable is Y. Now, for your convenience, what they told us, they gave us SXX, they gave us SXY, and they gave us SYY. And what are they asking us to find? Sometimes the question might stop here and they do not give you this part. They gave you the clarification, they're asking for R square, but even if they don't give you that green part, the meaning of the green part is in yellow. The yellow is the percentage of variation in Y, which is explained by the regression. It is R square. So even if the green part is not given to you, you are supposed to understand from the yellow statement that it is R square what is required. How do you find R square now? In this question? Which formula of R square? Formula of R square, one of them is R square equals SSR over SST. According to the available information, you will not be able to find SSR easily. There is an indirect way you'll be able to find it, but finding SSR according to the available information would be tough. So you will use this relationship between R correlation and R square. So you will find the correlation in this case, which is Sxy over Sxx times Syy square root. And then you will square it to get R square. And in this case, it should come out to be what? 982. So option A comes out to be the correct one. But this is only true for simple linear regression chapter 11. Chapter 12, you cannot use this relationship. U square, yes. Is this R or R square? R? 0.98 R. R. Give me this one without squaring. 982. That's it. $9,818. Then square it. So this should be E should be correct. 96.4 should be correct. The question is asking you for R square, not R. So you have to square it. Clear? Consider the regression equation. You see, many of the questions are less calculation, more output based. So focus on the calculation, but also focus on understanding the relationship between the numbers. Consider the regression where you have y hat equals 38. What is 38.02 here? B0, good. What is 0.774? B1. And the following, what is the sample size? 16, good. Also given here. Sometimes they give it up there and put question mark here, but luckily given at both occasions. The standard error of coefficient is given. The t value for the intercept is given, but for the slope is not given. The p value for intercept is given, but for slope it's not given. Find the value of A2. What is A2? A2 is the p value for checking the significance of slope, B1, beta 1. A2 is the p value for testing the significance of beta 1. So for testing the significance of beta 1, you don't need to write it, but you need to know that here is the hypothesis. This is the hypothesis for testing the significance of beta 1. And what is the t statistic? It is beta 1 hat minus 0 over standard error of beta 1 hat. What is beta 1 hat given to you? 0.774. What is the standard error? 0.5116. So the answer to t value is, then you have to find the p value. P value, is it a one-sided test or two-sided test? Two-sided. 2 times probability of t. What degrees of freedom? Degrees of freedom. For t, what degrees of freedom? Y15, Y14. 1x, when there is 1x, it is n minus 2, which is 16 minus 2, which is 14. T14 greater than 1.5129 absolute. So you will go to the t table and you will get this guy here, and then you will multiply it by 2. So when you get this T14 greater than 1.5129, T14, remember this, T14 greater than 1.5129. T14 greater than 1.5129. Where is this 1.5129? Between 0.05 and 0.1. Between 0.05 and 0.1. But the p-value is 2 times this. So the p-value is between 0.1 and 0.2. So the table says that This is between 0.1 and 0.2, but the p-value will be between 0.1 and 0.2, which corresponds to option D. Clear? Clear. Let's move on to question number 13. This is more of a calculation question. Data are available on the highway gasoline mileage performance and engine displacement for the Daimler, I don't know what vehicle, for model year 2005. A simple linear regression model relating the mileage to engine displacement was fitted using the following results. They gave you the sums, 5 sums. They gave you the sample size 21, SXX, SXY, beta 1 hat, beta naught hat, SST. SST, remember, it is SYY. SST is SYY. They gave you SSR, they gave you SSE. Almost everything is given. What is required? They ask us to construct a 99% prediction interval for the value of Y. Prediction interval. Why did I say value, single value? Why I didn't say the mean value? Because of the word prediction. Prediction is for the single value. Confidence is for the average value. So for this one, the formula given to you in the formula sheet is this. Now, what your job is to look at this formula and try to figure out a way how to get all of these values, how to get Y naught hat. The T value is given 2.861. This T value is already given to you. How to get MSE, how to get X naught, how to get X bar, how to get SXX. All of them one by one. Your job is to identify a way to find all of them. Number one, what is X naught? At what value do they want you to predict? 158. As a result, Y naught hat is B naught plus B1 times X naught. What is B1, B naught given? Given, right? It is given in the question. So you will easily find Y naught hat. $32.8 something. The next thing is how to find MSE. What is MSE? For simple linear regression, it is SSE over n minus 2. SSE is given or not? It's given. So it is 266.3927 over n minus 2. What is n minus 2? 19. You'll get MSE. Then the next thing is to find N. What is N? 21. Great. What is X naught? 158. What is X bar? How will you find X bar? Summation of X is given, N is given, so you will find X bar from there. How will you find SXX? It's given as it is, 238.151.8095. So finally, you will plug everything in and you will get the interval. From the interval, what are they asking you to report? Again, only the upper limit. Only the upper limit. So one of these options will correspond to the upper limit. Remember one thing, in quizzes or in exam, these simple linear regression questions, they are very sensitive to rounding. Very, very, very sensitive to rounding. Why? Because it's a long chain of calculations. If you round your answer for beta 1 hat, it will be carried all the way in all the calculations, and this rounding gap might pile up and it might make your answer different from the one which is in the option. So in exam or in quizzes, if your answer is slightly different on the third decimal or fourth decimal from the answer given, choose the closest one. In chapter 11 is very prone to rounding errors. Very prone to rounding errors. Okay. So usually what we do is for chapter 11, usually what's given in the question is when you do rounding up to 4 decimal points. So some of the students, they round it up to 3, some of them they round up to 5 and so on. If your exact answer does not match with one of the options, pick the closest one for a final exam. Remember this rule. So you plug it and you will get the answer. We move on to the next question. The next question says, consider regression equation. It's similar to question 12, I think, where we have B naught 38.02, B1 is 0.774, N is 16, and this analysis of variance table is given. Can someone tell me what does this 1 indicate? 1. This 1 indicates that the question is from chapter 11. One feature, one regressor. This is K. The degree of freedom for the numerator K, 1. This means you have one predictor in the regression. And the regression line is given to you. You can see there is one predictor in it, right? What does this 15 indicate? Total degree of freedom, which is N minus 1. This is the very big confusion point where many of you make mistake and consider this to be N. This is N minus 1. If we don't give you this N in the question and you have to find N from here, you should be able to recognize that N is 16, not 15. Okay. A very common mistake is we give you this 15, we don't give you this 14. And when we ask you to find the degree of freedom for the error, you do 15 minus 2, N minus 2. And you give 13, which is wrong. This 15 is already N minus 1. So you don't have to subtract 2 more. One more subtraction will make it N minus 2. So remember this point. Again, this is a ANOVA analysis of variance table where we're supposed to find all of them. Can you find SSR, which is not given? Let's find one by one. How do we find SSR? How do we find B1? SSR, SST. SST is given, SSE is given. So SST minus SSE. Calculators. Loud. 52.5. Then how do you find MSR? B2. It's SSR divided by its degree of freedom. So what is SSR divided by its degree of freedom? Same number. How do you find F? MSR over MSE. Do it. 52.59 divided by 22.97. In your exam, it can ask you for any of these. It may ask you for SSR, it may ask you for MSR, it may ask you for F, it may ask you for the p-value of F. Do it. 9. How do we find the p-value now? We'll go to the F table and look for probability in F distribution. Which F distribution? What are the 2 degrees of freedom? 1 and 14. Greater than 2.289. So let's go to the F distribution and look for 2.289. What was the degree of freedom again? 1 and 14. 1 and 14. What is the value here? What was your value? 2 point? Okay, continue. Next one. So your value is in between these two, correct? So the upper area is in between 0.1 and 0.25. So your p-value is between, this guy is between 0.1 and 0.25. Your value 2.289 was in between the first table and second F table. And for the first table, the value was 0.25, and for the second F table, the value was 0.1. So the p-value is between 0.1 and 0.25. Which is option A. Question 15. Regression method was used to analyze the study between roadway surface X and pavement deflection. Summary is given. Predict what pavement deflection would be observed when the surface temperature is 90. X naught is 90. Y naught hat is required. What do you want to do in this question? It's a very long calculation question. What will you do first? You will find SXX, which is 143,215.8 minus 1. Then you will find SXY, which is 1083.67 minus 12.75 multiplied by 1478 divided by 20. Then you will find beta 1 hat, which is SXY over SXX. Then you will find beta naught hat, which is Y bar minus beta 1 hat times X bar. And finally, you will do what? Finally, you will have this model. yi hat equals beta naught hat plus beta 1 hat times x naught. And this, in this model, you will put x naught equals 90 and you will get the final answer. So your job in this question was to fit the model, only fit the model, no prediction interval, no confidence interval, no hypothesis testing, no R-square, just fit the model, get B naught and B1 from the model and put 90 into the fitted model and get the predicted value. That's it. And it should correspond to one of these choices. Again, look, the question is categorically saying to round it up to 5 decimal points. Why? Because once you do calculation after calculation, the rounding errors, they keep piling up and sometimes the answer becomes too much different from the one that is given. So in most of the questions from chapter 11, we always recommend you to round up to 5 decimal points. But again, you can have some rounding errors. So if you see your answer is matching up to 2 or 3 decimal points and there is some difference on the 3rd, 4th, 5th decimal point, go ahead and select the closest option. Yes.
Why is
Option C is, I don't know what was the reason. Maybe what I did is one of them is the intercept value by putting x naught to be 0. Maybe 141 is the intercept of the line and the other ones are this. One of them is slope of the line. One of them is by putting 90. One of them is putting 9 maybe. So we try to anticipate what mistakes you will make. We make those mistakes, and the answer we get from those mistakes, we put them into the option. This is the same question. But what is the difference between these? Very conceptual question. I want you to look at the two questions at the same time. The font size is not okay, but I want you to look at the two questions at the same time. I will highlight what is required in the second question also. The other part is all the same. The only difference is the green part in two questions. The first one is asking about a single pavement deflection. And the second one is asking about the mean pavement deflection when the surface temperature is 90. How will you solve the second one? Say it. What you thought is correct. What you thought is correct. Say it. It's the same answer. Both of these questions have the same answer. We have repeatedly said that for the single value of y or average value of y when x is x naught, the point estimates are same. And both questions are asking you for the point estimate. They are not asking you for the interval estimate. They are asking you for the point estimate. So both of these questions will have the same answer. I remember for this question, I received many complaints that there is a printing mistake and we got two same questions. But there was no printing mistake in this one. It was deliberately given to check the concept, whether you know that the point estimate for the single value and the point estimate for the average value, they are the same. It is also true for chapter 12. The point estimates will be the same. The difference will come in the interval estimates. Let's move on to question 17. Again, a regression equation is given to you. A regression equation is given to you, n is given to you. This is the same question we solved. This one is asking you for the value of f. The previous question was asking you for the p-value. We already found the value of f to be 2.289. This will happen in final exam also, that the questions, they might be shuffled, but you will use the information from one question in another question. So 2.289 should be the correct answer. Is it there in the choice? Here it is. Option B is the correct. We already found this B3 in one of the questions. So 19. This is multiple linear regression. A multiple linear regression model produced the following summary. What is the summary? What is this S? It is nowhere given in the formula sheet, but it is the square root of MSE. Remember that. What is this R square? SSR divided by SST. What is R square adjusted? The formula is given to you in the formula sheet. It is 1 minus SSE over its degree of freedom divided by SST over its degree of freedom. So this is equal to 1 minus. What is SSE from the table? Its degree of freedom. SST. Its degree of freedom. 8. This should give you one of these options. And one of the hints, it should be slightly less than R square. Slightly less than R square. So if there is an option greater than R square, simply discard it. N is 9, correct. Option A, 91.6. Question number 20. A study was performed to investigate the shear strength. Y is the shear strength as it relates to the depth. Depth is x1, moisture is x2. Deceptively, the sample size is given here. I think it is used somewhere. N is 10. 10 observations were collected and we fitted the multiple linear regression. Here is the multiple linear regression. 171 is B0, 3.714 is B1, minus 1.126 is B2. Using this model, the predicted shear strength, what is predicted shear strength? Y naught hat. For a soil sample, when X1 is 18, X2 is 43, was calculated, but they did not give you. Afterwards, the actual strength for this specific sample was measured. Actual value was also measured. Y naught was measured to be 191.2. They did not give you the fitted value, but they gave you the actual value. What is the residual? What is the residual, by the way? Residual, not residual, the residual error. What is error? It is the difference between actual value minus predicted value, okay, or fitted value or estimated value, whatever name you want to give. Error is the actual value minus the predicted, fitted, or estimated value. They gave you the actual value. What is the actual value of moisture? 191.2. Now they want you to find the fitted value. For fitted value, what will you do? You will put the X values given to you in the model. So the fitted value Y naught hat will be 171.055 minus 3.714 times, what is the value of X1 given to you? 18 minus 1.126. What is the value of X2 given to you? 43. This will give you the fitted value, which is 100 and point. So the difference should be positive, which is B, D, 1.711. No, it can be negative. What if the actual value was 187 point something? It would be negative. Residual can be positive, can be negative. Multiple. Here? Yes. Where is it? We solved all of them. Yeah. Yesterday when I was pasting the questions, I think the last two I supposed to paste in 12 here, but I pasted there. I pasted 18 here, and I think 19 and 20 I pasted there mistakenly. I was supposed to paste 19 and 20 here. Now let's go back to 18. This is chapter 12. Very important question. The question says that you fit a regression model with two regressors. On a data set having n equals 20. The total sum of squares is what? And the model sum of square. What is model sum of square? Again, to make the things easier for you, in bracket they told you that it is SSR, but what if they don't tell you? The model sum of squares are the regression sum of square. What is SSR? 1000. I left some space here. I will tell you why. Suppose that you add a third regressor. So now you have a regression with 3 predictors. Now, when you keep adding more regressors to the regression model, the total variation in Y doesn't change. SSR changes, the variation in Y, which is explained by your regression. Whatever is the variation in Y is the variation in Y. Regression doesn't impact that. So your SST for this one will be the same, 1200. Your SSR for this one is given to be what? $1,100. This was 1,000 or 100? 1,000. Okay, now try to understand the question. The question says that the total variation in Y is 1,200. When you fitted a regression with two regressors, out of this 1,200, how much was explained by the two predictors? 1,000. When you added a third predictor, now how much is explained by the three of them combined? 1,100. They want you to test. This is a partial F test, remember, partial F test. They want you to test for testing the hypothesis whether adding the regressor improved the regression or not. I will write down the partial F statistic in front of you, and then I will tell you one by one how to find all those components. The partial F is equal to SSR of the full model minus SSR of the reduced model divided by R over MSE of the full model. And this full is not written in the formula sheet. So you have to remember that in partial F test, the denominator MSE is not the MS from there, it is MSE from here, from the three predictors, the bigger model. The denominator MSE will always come from this regression. Remember that. Now, what is SSR full? Which one? It is 1,100. What is the SSR for the reduced model? 1,000. What is R? This is a critical value. What is R? Is it 2 or 3? Should be 3. Should be 2. Should be 2 or 3? 2. Should be 2 or 3? 3? Anyone who disagrees with 3, should be 2 or 3? Okay, let me ask you in a different way. Okay. Whenever you write something in F, it is actually the total contribution by all the predictors. I'm talking about the full F test. You divide it by K. Why? Because this is the contribution of K predictors, total contribution of K predictors. You divide it by K to make it the mean contribution, not the total contribution, mean contribution. So if this is the contribution from K terms, you divide it by K. Correct? Now this whole thing is the contribution of how many predictors? SSR full is the contribution of how many predictors? 3. SSR reduced is the contribution of how many predictors? 2. So there were the total of 3 predictors. You subtracted the contribution of 2 of them. How many predictors are you left with? 1. R is the number of predictors you add to the reduced model. In this example, it is not 2, it is not 3, it is 1. In this example, how many predictors you added? 1. So it's the contribution of 1 predictor actually. You are subtracting from 3, the contribution of 2, you are left with 1. Now, to make it average contribution, you will divide it by 1. So let us plug in everything. You have 1,100 minus 1,000 divided by 1 over. How will you get MSE of full model? It's not given. Total, no. MSE. Error over n minus k minus. But how will you get error? It's not given. Yes, for the full model, first you will find SSE, which is SST minus SSR. 1200 minus 1100, which is 100. Now, what about the degrees of freedom? Full 100 over. What was n? N will not change for full or reduced. N will not change. What is the n given to us? 20. Okay, good. 20 minus what is k for full model? 1, 2, or 3? Full model 3 minus 1. N minus k minus 1. So this is 100 divided by 16, which is 6.25. Use 6.25. You have 100 divided by 6.25. 16, which corresponds to this 16. So you see 6.25 is there. 20, which is the sample size, is there. You know how this 5.88 comes? If you make a mistake in R, you choose R to be 3 or R to be 2, you'll get 5.88. 17, how will you get 17? If you, instead of putting MSE of full, you put the MSE of the reduced model, you will get 17. Instead of MSE of the full model, if you calculate the MSE from this model and put it there, you'll get 17. So any possible mistake you make, you will get one of these answers. And then you will confidently circle it. So this is it. This is the practice from chapters 11 and 12. I have 7 minutes. Let me bring another question from maybe if I have another example. This was 241, so let me bring it from 233. Let us just discuss and not solve anything. I'll just give you the hints. I'll start from the bottom because initial questions are from old chapters. The upper end boundary of a 95% confidence interval. The upper boundary of a 95% confidence interval for increase in electric power consumed for 1 Fahrenheit increase in ambient temperature, holding the other predictors constant, is. Where is this question coming from? They must have given some output somewhere. Here is the output, and they are asking us to use this output to solve the next 6 questions. So let us first look at this output. In this output, they say that the electric power consumed each month by a chemical plant is thought to be related with the temperature and number of days and the product purity and the product produced. There are 4 predictors: X1, X2, X3, and X4. Data are collected and the resultant regression and ANOVA table. ANOVA table, there is a capital A missing before the NOVA. It's not NOVA, it's ANOVA. We call it analysis of variance table. It is shown here in this table. Lucky for you, the whole coefficient table is given, but there are some values which are missing here. So let us first fill the missing values. The degree of freedom for the regression is missing. What is that going to be? 4. Good. The error degree of freedom is missing. What is that going to be? No. 11 minus 4 or n minus k minus 1. Your n is 12, k is 4 minus 1. 12 minus 4 is 8, 8 minus 1 is 7, or simply 11 minus 4. 11 minus 4 will give you 7. SSE is missing. How will you get SSE? Yes. Here SSE is missing. So you will have 6572 minus 5600. Then MSR is given, MSE is given, F is missing. How will you find F? MSR over MSE 1400 divided by 138. So you will get the value of. Now let us look at the questions one by one. Question A says that the predicted power consumption for a month in which X1 is this, X2 is this, X3 is this, X4 is this will be what? You just substitute. This is B0 minus 123 point something. This is B1, this is B2, this is B3, this is B4. So just substitute in your model the values and you get this one. To test the overall significance, what is the value of statistic? How do you test the significance of the full model? How do you which test do you use for that one? Do you use full F test or you use partial F test or you use a T test? Full F test. So we already found the value of this test statistic F here, somehow MSR over MSE. Just give that answer in question 16. The required thing in question 16 here is the value of F for the full F test. Should be 10.01. The proportion of total variability that is explained by the model. What does this statement mean? This part means R square. The proportion of variation that is explained by the model. This part means R square. What does this part mean? Adjusted. Adjusting for the sample size and the number of variables. Taking into the account means adjusting for that one. So what is required in this question? R square adjusted. Using the T test to assess the contribution of each predictor at 5%, the critical value, what should be the critical value for the T test? For this one, you need to know, number one, alpha, which is given in the question 5%. Number two, the degree of freedom for T. What is the degree of freedom? And minus K minus 1 for this chapter. So wherever you need to use T, out of these 3 degrees of freedom, which one will you use? You will always use the error degree of freedom here, which is 7 in this case. For chapter 11 and 12, wherever you use a degree of freedom for the T, which one will you use? Error 1, N minus K minus 1. Wherever for the prediction or for testing the significance of a single predictor or for mean response, wherever you need a T critical value, the degree of freedom will be the one from the error. The one from the error. Remember, so you will have 7 degrees of freedom in this question. So you will go to the T table with 7 degrees of freedom and for alpha or alpha by 2. Alpha by 2. Significance tests are two-sided, where you are testing beta 1 equals 0 against beta 1 not equal to 0, not greater than, not less than, not equal to 0. So for the testing significance, they are all two-sided tests. Using the T test to assess the contribution, we conclude that only one predictor is significant. All of them are significant. You can only we can see it from the p-values. Look here. How many of them are significant? Look at the p-values. How many of them are less than 5%? Only one of them is significant. So one of the options probably is saying that only one predictor is contributing significantly. Is it? Only one. Are all contributing significantly? No. Are 2 contributing significantly? No. Are none of them contributing significantly? No. Are 3 contributing? So 1 is contributing significantly.
The value of alpha.
Not the value.
The smaller value.
The number of p-values which are smaller than alpha. The upper boundary for the confidence interval, 95% confidence interval for the increase in electric power consumed for 1 Fahrenheit increase in ambient temperature. This is one of the beta coefficients. Which one? I don't know which one. Whatever variable is this ambient temperature. Is it X1, 2, 3, or 4? Ambient temperature. ambient temperature. It's X1. So it is asking you to construct a 95% confidence interval for beta 1. This whole thing, the one I have highlighted, is the meaning of beta 1. What is beta 1? It is the average change in electricity consumed due to 1 Fahrenheit increase in ambient temperature, keeping the other predictors fixed. This whole sentence is beta 1. So they're asking you to construct a 95% confidence interval for beta 1, which is what? Beta 1 hat plus minus a critical value times the standard error. Where will you get the standard error of beta 1 hat? They are given in this table here, the second column, standard errors. So it should be 0.7573 plus minus critical value from the T multiplied by this standard error. You'll get lower and upper limit, and probably the question is asking you for the, it's asking you for the upper limit. So upper limit should be 1.4173. Let us wind up the class here. I will see you on Tuesday with some questions, most of the questions from chapters 9 or maybe some previous chapters, but mainly from chapter 9, mixed up with 11, 12, and previous